So today's class will discuss how to saturate NPN transistor. Okay, okay. So let's learn that. So let's say we have a circuit, very simple circuit. We have VCC, then we have a resistor, collector resistor, RC, and then transistor. Okay, and this is our RB, and this is where we are applying base voltage. Okay. And let's say we have another circuit. This is the same circuitry but with little different configurations. So RC, there is one transistor, then we have RV, we have one more resistor here, the pull down resistor. This is RV1 and this is RB and this we have PV. So let's say give a name of this is a figure 1 and this is a figure 2. Okay. So So before doing that, let's say what is the procedure to make the transistor in saturation region? So procedure one. So depending on your circuit configurations, right? Define current set point for either the base or collector. Okay. So set or define set point. Rather, I say define a set point. Define the set point for either the base current or collector current. Now, step 2 is set the collector current to base current ratio of 2. Set the IC by IV ratio equal to 2. Now, you can ask why 2, why not any other? You can choose any other value. Maybe you can choose 10, we can choose any value, but for coming to deep saturations, I'm choosing 2 here. As this IC by IV ratio will be more, it will be like sorry, it will if you choose IC by IV ratio is very less, it will go into more deeper saturation. Okay, and that's what our intention is to. Okay, next is based on this selection, compute the resistance value. Compute the resistance value, and then step 4, you double check the circuit. Okay, using a selected register or using the selected values, using the selected values. Okay, so let's proceed. Okay, so in the first application in figure 1 I have choose this circuit. So this is your a simple circuit or any fundamental circuit of transistors. So RV, one base resistor, this is VB, and this is the RC. This is what our circuit now. Now, most of the application, this VB is provided by the microcontroller, okay, or any small power circuit. It is a good practice to consider the base current set point such that it will not exceed the microcontroller or small power circuit rating. Okay. For example, the maximum source current that can be provided by MCU. Let's say we have one MCU and this circuit is connected. Okay, so let's say we have connected this circuit to the MCU. So this is your RB, this is your RC. And now let's assume this microcontroller P maximum current capability is 4 milliamps. Okay, so the base current IV, we have to choose at least 75% of these, 75% of these, okay, as a set point. So current of almost 3 milliampere. So it will not overload the microcontroller pin or it will not damage the microcontroller. So now the step one, as per the step one, select the circuit configurations. So we are considering that VBE is equals to 5 volt, then VCC is equals to 10 volt. Okay. So first consideration is over. Now come to the second point. Second point, I am setting the base current. Let's say IV is equals to 3 milliamp. As a 75% of the 4 milliamp, considering 3 milliamps. Microcontroller pin has a capability of 4 milliamps. In that case, I am considering IV is equals to 3 milliamps. Now, third step, I am selecting the collector current to base current ratio. So IC by IV ratio is equal to 2. Or even you can choose lower value or upper value depending upon your needs. So the ratio of 2 is why, the reason is it is in a very hard saturation already. It's very hard saturation. Okay. Okay. So if now IC by IV ratio is equal to 2, then IC value is equals to 6 milliamps. Okay. Now you got it. Now fourth step is solve for RB. You will get the RB and RC value, right? So in case RB is equals to, very straightforward, VB minus VBE by IB, right? So I'm assuming this VB is equals to 0.7 volt. So let's say 5 minus 0.7 divided by, what is IV, is a 2 milliamps, right? I sorry, IV is a 3. I'm sorry, 3 milliamps. So we can check what will be the value of the IRB. So 5 minus 0.7 divided by 3. So 1143 kilo ohm. Kilo ohm. Okay. Now, next we want to calculate RC. So the 5, not 5, is a 4.1, I guess. So RC is equals to, I am choosing VCC by IC. Your VCC is a 10 volt and 6 milliampere is a ICI. So for simplicity, I am just ignoring the VC saturation drop. It's almost very less. You can consider it for worst case. So 1.67 kilo, and you can choose this register value very close, whatever nearest value available in the market. So now we got RB, we got RC. Now it's time to double check or cross check using whatever value we got. So let's double check. You can do simulations, like you can select here one resistor, here resistor is a 10 volt. You simply choose the BC 817. I have checked that. Then here 1.43 kilo ohm, and then this is the RV. This is a 5 volt. You can simply check it in the LT Spice. or symmetrics, or else I'll show you the next video. And you'll get closely this or completed result, whatever IC and IV. You'll get IC, you'll get IC around 6 milliamps. So let's continue in the next class.